Welcome everybody to this webinar. Thank you for joining us today. We are going to talk about launching virtual machines using the command line OpenStack interface. So as you probably know, the Alliance Federation provides free cloud resources on a number of national systems. So the biggest cloud system in the Alliance is called Abutus, but we'll also have several other systems. And the list of these is in our wiki page, which is linked from the notes. So the list is always, is constantly updated. So for example, in the next few months, we're going to have a transition from Cedar Cloud to Fur Cloud. So as you know, Cedar used to be the NHPC cluster here at Simon Fraser University. Now we have Fur, but we're still running cloud on the old Cedar partition because not all hardware has been installed yet for the Fur Cloud. So same with Abutus is going to evolve. So right now, Abutus is mostly available as version 1, so the old hardware. But over the next few months, Abutus version 2 is going to come online for everybody. So right now it's just in the testing stage, but in a few months, hopefully, it'll be available for everybody. So the idea is that on any of these systems, you can use your Compute Canada, well, not Compute Canada, the Alliance account to enter a project and then create virtual machines in this project. To get started, you will need to ask for a project on these clouds. So the details are in this page, which is linked from the notes. But essentially, all you need is an Alliance account and then a project, and then you can log into the web UI and then start creating machines. So this is the workflow, which is fairly standard, and we had actually quite a few webinars on this in the past. So if you click on this one, you will see that here we had a webinar a year ago, exactly, introduction to the Alliance Cloud. And then we had several other cloud webinars as well. So what is different today is I'm going to show you how instead of using the web UI, you can actually do everything as launch virtual machines, attach volumes, create snapshots, etc., using the command line interface. And in my opinion, the command line interface is vastly superior because with the web UI, you have to know the menus to do anything, and there are hundreds of mouse clicks. And I find that the whole thing is really, really clunky, and it takes half an hour to create a virtual machine and then attach volume to it. Whereas using the command line interface, I can do it just within a few minutes. Essentially, there are just like 3 or 4 commands that let you do everything. So in order to use the OpenStack command line interface, you need to install it. This is how you would do this on your own computer. So this is a webinar, so just watch the presentation, and then you can do this after the webinar. But to install it, essentially, what you do is you use any standard Python installation tool like pip or UV, or perhaps Conda would work as well. So here is how I installed it on my own computer. Using Python 3.12, and basically I just created a local environment in my home directory. And in this environment, now I have a binary utility, OpenStack. So all OpenStack commands that I'm going to run today, I'm going to run on my own computer. And then once the virtual machine is created, then I can log into the virtual machine and run things there. So install software, attach volumes, etc. But the OpenStack command itself, I'm going to run entirely on always on my own computer. So the first step in the process. So first, I'm going to walk you through launching a virtual machine. And there are 5 fairly easy steps. And actually, most of these steps, once you do it often, most of these steps are not necessary. So a lot of them have to do with authentication and your initial setup, things like uploading SSH keys, etc. So we'll see in real life there are fewer than 5 steps, but here I just walk you through the entire process. So step 1, you'll need to authenticate yourself. And for this, you still have to use the web UI. Because you will need to download a configuration file that you source locally on your machine, and that will authenticate your command line interface to the cloud that you want to use. So here I'm prepared to run demo on 2 clouds, so either a Cedar Cloud or the old Abutus Cloud. So I think for this demo, I'm just going to use the Cedar Cloud, and I'm going to open the website. So this is the usual OpenStack web UI interface, which is called Horizon. And here, the only thing that I need is download the configuration file. So if you have a project on, let's say, City Cloud, you will see upon login, you will see a drop-down menu where you have access to maybe one, maybe a few projects. So I'm going to be using CC internal as a few training project that I have access to. So again, for every user, you have to request, every user needs to request access to a project, and then you will be able to use this UI to authenticate yourself. And then here in the drop-down menu on the right-hand side, I will click OpenStack, download OpenStack IC file. So I'm going to save this file into my downloads directory. And then I'm going to, in the next step, I'm going to source this file to authenticate my command line interface to use the Cedar Cloud. So let me switch to the terminal. And then I'm going to go into a directory from which I'm going to run all OpenStack commands. And then into this directory, I'm going to move my just downloaded file. So the CC internal SFU training open ic.sh file. I'm going to move it here. So the name of this file is going to depend on your project. So obviously it reflects the project name. So for every user, it might be something different. But the bottom line is that it is a shell script that you can source yourself. So before sourcing the shell script, I'm actually going to activate the OpenStack virtual environment. So this is the environment that I installed into my home directory. So I'm going to run this command. And that gives me access to the OpenStack command. So for example, I can run OpenStack --help, and it will probably give me some manual page on how to use it. So I source the environment. Then I'm going to source the CC internal SFU training run command file .sh bash script. And that will prompt me to enter a password. And for the password, let me find my window. And now I'm authenticated. So now I can actually run OpenStack commands, and all commands will apply to my instances on Cedar Cloud. So the next step is deciding on the virtual machine flavors and images. So in OpenStack, a flavor defines the hardware configuration. So essentially, it's things like the number of CPU cores, the type of CPU cores, RAM, so memory, and perhaps disk size as well. So in our cloud, so everywhere, whether it's Abutus, Cedar Cloud, Nibi Cloud, etc., there are two types of flavors. Compute flavors that are intended to run for a limited time, and they are quite meant to be quite CPU intensive. So we allocate quite a few resources internally for them. And these are good for doing things that are, let's say, CPU intensive or GPU intensive. So for example, you're doing some code development and you need to run your code often, or you need to compile your code often, or perhaps maybe you create a virtual machine to build an obtainer image, etc. So all these things are quite CPU intensive, and for these you probably want to have a C flavor. So these are CPU intensive, but short, well, flavors that do not run for a long time. On the other hand, if you need something persistent, just sitting there in the background and answering requests, let's say running a web server or data portal or a web application, then you can spawn a P flavor. So P flavors have a few resources. They're not really meant for heavy CPU usage, but they're really great just for sitting there and then processing incoming requests. So in order to list flavors, you will need to available flavors on Cedar Cloud. So here I authenticate myself against Cedar Cloud. You can run this command OpenStack flavor list with the American spelling. And that will contact Cedar Cloud and inquire about the available flavors. So the flavor, once again, is a virtual machine configuration available to me in my project. And here you see there's a handful of flavors. So here's the column we'll be looking at. So one of the smallest one is, actually this I guess is the smallest one, is P1, 1.5 gigabytes. So this refers to persistent flavors. So P means persistent, C means compute flavor. So persistent flavor, so slower virtual CPUs. Just one P1 means there is just one CPU core in this flavor. And then RAM is 1.5 gigabytes. So it's a tiny machine, but it actually turns out that even this tiny machine, which is really, really small compared to modern-day laptop, let's say, it might be sufficient for testing, for running quite a lot of different workflows. If you need more resources, you can certainly ask for more resources. So let's say this one will give you 8 persistent cores, so slower persistent cores, and then 12 gigabytes of memory. So I'm going to use this flavor C2 15 gigabytes 31, which should be somewhere right here. I'm going to use this flavor. So this stands for compute vCPU, compute flavor vCPU, so a little bit faster CPU cores. Two CPU cores, 15 gigabytes of memory, and then 31 refers to the size in gigabytes of the ephemeral disk. So I'm going to talk about different disk types, so ephemeral disk, volume disk, system disk very shortly. So now also we need to decide on the operating system. So to list the operating systems available to you, what images are available to launch a VM, you run this command. So OpenStack image list. And that will give you about 20 or so different operating system flavors, and all of them are obviously Linux. So I'm going to use Ubuntu 24.04, the latest Ubuntu. But of course, you can opt in, let's say, for Alma Linux, that is run on most of our clusters, or you might want to use the original Debian or maybe Fedora distribution, etc. So it's completely up to you which one you use. I'm going to use Ubuntu 24.04. And if you want to get more information about let's say, what's included into a flavor, then you can run this command, OpenStack. So here I chose to run, I'll be running this flavor, C2 15 gigabytes. And if you want to get more information of what's included in this flavor, you can run a command like this. So it will give you a lot of information. And then you can narrow it down by, let's printing only the disk size and the amount of RAM that will be available to you in this flavor. Right. So in this case, it's going to be 20 gigabytes refers to, so remember that here I mentioned 31 gigabytes. So 31 gigabytes is the ephemeral disk. And then 20 gigabytes is the the system or the root partition. So there will be two large partitions when you spin up this VM, and then RAM in megabytes. Here's 15 gigabytes of memory. So once again, you'll need to choose two things. So the flavor, and then the operating system image. And then finally, when you spin up your VM, you also need to know the name of the network, internal network that this machine is going to be attached to. So by definition, when we create a project for you, your project will have a similar named network, and essentially that's the network you should be using. So if you don't know its name, here is a command to check its name. So OpenStack network list will list all internal networks that are available to me in this project. And this is the network I'm going to be using. So it has the same name as my project. All right. So with these three things out of the way, next thing we need to do is create an SSH key pair. So creating an SSH key pair is very easy. We actually have several web pages in our wiki documentation on doing this. So whether you're on Mac, Linux, or Windows, you can follow these pages. So I'm on a Mac. So in a Mac, I would probably go into my .ssh subdirectory in my home directory, and then I will run this command. So cd key will be the base name of my SSH key pair. And when I run this command, so I won't do it now. I ran it. I did it before. But essentially, this will take a few seconds. It will ask me for a passphrase, and it's a very good idea to enter a non-empty passphrase because a passphrase is important to secure your own key. And then in the next command, I'm going to add it. So this is a macOS specific command. I'm going to add these key to my keychain. So that means that essentially I won't have to enter the passphrase every time I use this key. So these two commands will be different depending on the operating system. They'll be similar but different. So again, if you're on Linux or on Windows, just follow the instructions that are linked from the notes. So with this, let me show you what it looks like on my own computer. So in my own computer, I already ran these commands before. And so running this command will generate a key pair. So here's my private key, and here's my public key. So the private key should remain private. You should never share it with anyone. And then the public key, I'm going to upload to the CD cloud. All right. So next command, I'm going to list the currently uploaded keys. And you will see that the cd key I already, because I experimented with this setup yesterday, already uploaded to the to cd cloud. So here are the keys that are available to me. One of them is for all staff, all Align staff that have access to this project, and this is my own personal key. So if I want to delete this key in the cloud, this is the command I would run. So I would say OpenStack key pair delete cd key, and that would delete the key, and then I would have to upload it again if I delete it in the cloud. So to upload the key, this is the command you would use. So I won't run this command because the key is already uploaded, but just the point is that when you list the keys that are sitting there on cd cloud, the key that you want to use should be listed there. And then the next step is to launch the virtual machine. So this is the command that, in my own workflow, I don't have to create the keys. I already know the flavors and the images. So when I start creating a virtual machine, this is essentially the command I run, right? So here what we're doing is we're launching a virtual machine instance, specifying the flavor. So once again, this is the flavor I'm going to be using, 2 CPU cores, 15 gigabytes of RAM. Then I'm going to be bootstrapping from the Ubuntu image, Ubuntu 24.04. I'm going to attach this internal network to my machine. I'm going to attach this cd key that has been uploaded to cd cloud to this machine, so I can use my private cd key to log in to this machine in a few minutes. And then you probably want to specify the security group as well. So I have not talked about creating, I'm going to talk about creating security groups soon, later on. But for now, I'm just going to be using the default security group. And security group basically contains rules for accessing the machine. So the default security group has only one ingress rule. So you can only access the machine via SSH on port 22. But if you want to open other ports for, let's say, running a web server or some other data server, then you can certainly create new security groups. I'm going to show you how to do it later on. And then Alex Demo Box is just going to be the name of my machine, right? So I'm going to create a virtual machine instance that is called Alex Demo Box. So let me do this. So I'm just pasting these commands, and let's see what happens. So this should take a few seconds. And the machine has been created. So these are various parameters, attributes of this machine. In order to check that it's active, I'm just going to run OpenStack server list, and that will list all instances that are currently running in this project. And as you can see, the machine is currently in status build, so it will take a few more seconds for this machine to be active. So let me check the dashboard. I'm going to, as you see previously, the dashboard was showing 0 instances, 0 CPUs, and then no RAM being utilized. So I'm going to refresh that. And as you can see, now I'm running one instance, right? So I have just one virtual machine. That virtual machine has 2 CPU cores, and then it uses 15 gigabytes of memory. So let me check the status once again. This should be done by now. So, and the status is active. That means that the machine is up and running. So as you can see, it took, I don't know, half a minute or around 20 seconds to spin up this machine. So before we can access it, I need to associate a floating IP. So a floating IP is an externally facing, it's a public IP that I will be using to log in to my machine. So in order to get a floating IP, you need to run this command, OpenStack floating IP, create public network, and that will create a publicly facing IP, which is this one. So this one, I'm going to write it down because I'm going to reference this IP multiple times in today's workshop. And then I'm going to attach this IP to my machine. So I'm going to say OpenStack server add floating IP. This is my machine's name. And then I'm going to copy and paste the floating IP address here. So if this command is successful, that means that it did not complain. There are no errors. Now my machine is running and I attach the floating IP. So now I can use this IP to log into my machine. So let's connect to this machine. So I'm going to run this command, SSH. The default username for an Ubuntu image is going to be Ubuntu. So this is a sudo user that has some sudo privileges. For example, that user can install software. So I'm going to say SSH Ubuntu add, and then this floating IP, and then I'm going to specify the key I'm going to use. So this part is very important because this is not the usual SSH key I use to log into, let's say, HPC classes. This is the key I specifically created for this demo to be able to connect to a virtual machine running on Cedar Cloud. All right. So it says, are you sure you want to connect? I'm going to say yes. And then it will log me into the machine if the machine is currently active. And now we're done. So as you can see, starting from the point when I ran the command to launch the machine and to now when I successfully logged into the machine, it only took a few minutes, right? So now I'm inside the machine. So I'm going to log out, and I'm going to modify my SSH settings so that I don't have to type this command every time I wanna log into the machine. So I'm going to edit my file. I'm going to add the following to my ssh.config file. So I'm going to paste the following command into my terminal. So in this command, what I'm doing, I'm adding the following text to my .sh config file. So essentially, it's an entry that says that there is a new remote system called Ubuntu. Here's the IP address of the system. Here's the username that I'll be using to connect every time I connect to the system. And here's the identity file that I'm going to be using. So it's sitting locally in my .sh directory, right? And the whole idea of this is just to replace this command. So instead of typing this complex command from now on to connect to the machine, all I need to do is just type Ubuntu, SSH Ubuntu with this configuration, and then I'm inside the machine. So now I logged into the machine, and then I want to install some software. So the first thing you want to do is probably you want to update, since this is Ubuntu. For Ubuntu, you use the apt or apt-get command to install software. So I'm going to update the list of packages that I can install. So this will take a few seconds. Okay, so now we updated the list of packages that we could install. And then I'm going to install a couple of, well, actually 3 commands, wget, bud, and btop. So here, let's see, btop is currently not available, right? It shows that btop is not a package installed locally. So let's install this package along with wget and bud. So I'm going to run this command. And of course, as you can see, this is sudo. So I'm running this as Ubuntu user. So that user has a sudo access. I can install packages. So here I'm installing 3 packages. And let me run btop. Now btop has been installed. So btop is just a nice utility for looking at system resources. So memory, processes, disk usage, network, etc., etc. So of course, in real life, you probably want to do security update as well. So the command to, in this case for Ubuntu, to run the security update is going to be a sudo upgrade, and then you have to reboot. So I'm not going to do this now because this will take, I don't know, something like 5 or 10, maybe 15 minutes. But the idea is that every time you create a new machine, you probably want to do the security updates. So upgrade all the packages and apply all the security patches. But again, I won't do this now because we don't have a lot of time in this webinar. So in Ubuntu, you can also install snap packages. So this is a different package installer that installs self-contained applications, and all of these go into the /snap directory. So just an example, and then they run in a sandbox, right? So kind of isolated for additional security. So this is just another way of installing packages. So let me install Emacs, classic Emacs. This is the command I would do to do this. So this might take, I don't know, up to a minute, hopefully not too long. So now it is installing the Emacs snap package, and it's going to install Emacs version 30 point something. So we'll verify this in a few seconds. So as you can see, it's this fairly large download, so several tens of megabytes. All right, And now we're done. So now I can actually run this version of Emacs, the snap version of Emacs, and it should report that it is Emacs 30.2, as you can see here. So let me exit Emacs and then go back to my notes. So here's a useful couple of commands. If you want to use this virtual machine to build Obtainer images, or which we always recommend for a clean image. So with Obtainer, you can create container images that you can run on HPC clusters, but then ideally you want to have a dedicated Linux machine for this. So one really good use of virtual machines is to create Obtainer images. So in that case, you would install Obtainer using these two commands. So optionally, I like putting my own configuration files. So for that, I use a private GitHub repository. So you don't have access to this repository, but this is just a repository I created for my own use because I work with many different remote systems. And on each system, I want to have the same, let's say, .bashic file, the same .emacs configuration file, etc. So in order to do this, I will need to clone the Git repository from a GitHub repository onto this virtual machine. And to access a private GitHub repository, I will need my GitHub private key. So in order to do this, I will use SSH agent forwarding. So I logged out from the virtual machine, and now I'm going to log into the same machine using -E flag. So this will forward essentially my private SSH key to the machine, not copied, but forwarded in RAM. And that way I'll be able to clone a private repository from GitHub onto this machine. So let me actually start Tmax just in case if it takes a while to do this. So sometimes GitHub might be not responsive. And so here I'm going to run the GitHub clone command. So hopefully, so it asks me, are you sure you want to do this? I'm going to say yes, because this is the first time I access GitHub from my virtual machine. And actually, it works very smoothly, right? So here it cloned the repository, and then I'm going to remove the my .bashic file, default bashic file, and then create a link to a file inside this project, inside this repository, and then I'm going to do the same for Emacs, Emacs, so that next time when I log back into the machine, I actually have my own setup and my own prompt and my own aliases, etc. So now let's talk about disk storage. So at this point, we can actually run df and see what volumes are attached. There are a number of volumes. So the two big ones are this 31 gigabyte volume, which is the ephemeral disk. So this is the one which comes from our flavor specification. So remember, it had 2 cores, 15 gigabytes, and then 31 gigabytes of space. So that's ephemeral disk. So that's the disk which exists. So ephemeral means temporary. It exists only for the lifetime of my instance. So when I delete the instance, that everything, all data stored in this partition is going to disappear as well. And then there's the root disk as well. So this is, it shows 19 gigabytes, but somewhere earlier we saw the number 20 gigabytes, so it's probably close to 20 gigabytes. So this is where the operating system itself is sitting, right? So when we, let's say later on, when we create a snapshot, the snapshot is going to capture everything inside this system directory. So basically, your operating system as well as any packages you installed in your virtual machine. So all of these go into your system disk, and the system disk can be saved via a snapshot. So whereas the ephemeral disk, this guy is temporary and it's not saved in the snapshot. So if you need more space, you can create and attach additional volumes. And again, all of this is super easy to do via OpenStack command line. So let's say I want to, on the same City Cloud, let's say I want to have a 100 gigabyte volume, so additional disk that I'm going to attach to my machine. So in order to create this volume, I'm going to run the following command: OpenStack volume create -- size 100. So this stands for gigabytes, 100 gigabytes, and then followed by the name of this volume. So I can call it whatever I want, right? It just has to be a unique name. So I'm going to call it demo volume. I should not run this command on the remote system. I should run it locally in my OpenStack virtual environment. So here I create this volume. The volume, as you can see, has been created. So these are various attributes. So if you want to see, let's see, the status of the volume, so whether it's already available or still being created, is being created, right? So here in the row for available, you see that now this 100 gigabyte volume has been created and is available for use. So next step, I'm going to attach this volume to my virtual machine. So I'm going to run this command. So here I'm simply attaching the volume, demo volume, this 100 gigabyte disk, to my virtual machine. Done. So now it was attached to my virtual machine using this device name. So device VDC is the name of the device under which this volume is attached to my machine. So let me SSH back to the machine. And then I can run this command to list all block devices. So the VDC disk, 100 gigabyte disk, should be listed as one of them because I just attached it to my virtual machine. So here it is, it's available, but I need to format it and then mount it before I can use it, right? So these are steps which are very familiar to everybody who's been, running Linux on their own machines. But if you are new to Linux, running Linux, then any new volume that you can create in the setup, you have to first format, and then you'll have to mount it with two separate commands. So I'm gonna format it with Linux as a Linux extension for ext4 file system. So this is the modern Linux file system. I'm very important when I format the volume to specify the right device name, right? So I'm gonna do this VDC, device VDC, which is the 100 gigabyte disk. So now it's creating the journaling file system. Done. The volume has been formatted. So next I'll need to mount it. So I'm going to create a top level directory that I can call it anything I want as long as it's a unique name. So I'm going to call it data, right? So now under / in the top level root directory, there is a subdirectory called data, and I'm going to use this as a mount point for this partition. I'm going to mount my device under data. So that means that when I go to data, now I actually have access to a volume which originally was 100 gigabytes, but as you can see, a few gigabytes of these is taken by, I don't know, various formatting things. So it actually, the available size to me is 93 gigabytes. And then I'm gonna create a temporary directory here as sudo. Sudo user can create directories in this volume. And then I'm going to give ownership of this directory data TMP in this new partition to the user Ubuntu, and also the group ownership is going to be the same as the username. So these just make sure that the user Ubuntu can read and write files inside this directory without having to use sudo. And then I'm going to organize a symbolic link. So now I go back to my home directory, and inside my home directory, I have TMP folder. So if I, as regular user Ubuntu, I go to this folder, now this folder actually takes me to my 100 gigabyte disk, in which I can, create files, modify files, create directories, and so on. So if you want to run a web server, typically you will have to open some ports because the default security group allows only incoming SSH traffic on port 22. So let me list all currently available security groups. Oops, of course, I need to go back. I'll always make this mistake. So I need to run OpenStack commands on my own machine. So I'm going to list the security groups currently available in this project. As you can see, one of them, there are a few groups that some other users created, so I don't know what these are. But the default one is this one. And this one only allows, so in order to show the details of this group, I can say OpenStack security group show default. And that will show me that currently it only allows ingress, so incoming traffic, on port 22, which is the SSH port, right? So in other words, the only way I can access this machine from outside is via SSH on port 22. But let's say I want to run a web server that will listen for incoming traffic on port 8080. So how would I do this? Well, the best option is to create a new security group. So I'm going to call this rule 01. So I'm going to call a new security group by running this command. Again, I'm running this command on my own machine, right? OpenStack command. So I create a new security group. I'm going to call it rule 01, and the description is this group will be used to allow incoming traffic. I think it's truncated here, but incoming traffic on port 8080. So here we go. the group was created. And then inside this group, I'm going to create a new security rule to allow traffic. So inside this group, rule, it's a little bit truncated. Rule 01, I'm going to allow incoming traffic on port 8080. So here we go. And then I'm going to attach this security group to my machine, to my instance. So the security group that allows for incoming traffic on port 8080 is going to be attached to my machine. So optionally, you can set up Git. If you're going to use a virtual machine for development, then you probably want to set up Git and all the usual Git settings that I'm not going to do now because this is just for your own information. But it's very useful to set up Git. Things like your email address, your name, various Git aliases, etc. So what I'm going to do now is you can run remote graphical applications in a number of different ways. So you can do X11 forwarding that is slow, or you can install some sort of a server to enable a remote desktop. So you can do this also via browser-based apps, things like NoVNC or Apache Guacamole. Again, because this is your own machine, all of these you have to do yourself, right? So I'm not going to demo this now because this would take quite a long time, but I can probably open. So let's see if I SSH into this machine, and let's see if I will check quickly if I have Xterm installed. So Xterm, okay, Xterm is not even installed. So let me install Xterm, and then I'm going to show how I can run this Xterm application remotely with X11 forwarding, which is not the best option, but it's just the fastest option for this demo. So here I'm installing Xterm, and as you can see, it comes actually with a number of dependencies, X11, so X Windows dependencies. And we're almost done. So now if I try to run Xterm, of course, it will tell me cannot open display. So it's trying to open a graphical application because a display display forwarding is not set up. So I'm going to log out, and then I'm going to log into this machine, passing the flag -X to SSH. So that will enable display forwarding, X11 forwarding. And now, once I'm on the machine, I can run Xterm again. I can run Xterm again, and then what will happen is it will open a window, remote graphical window on my local machine. So here it's just open in a different terminal. So here's the window it opened. As you can see, this is the Ubuntu machine on which I can actually run applications. But again, I certainly do not recommend. So here's just quickly to show you that I can do X11 forwarding and open remote windows, but of course, this is the slowest option. For faster option, I recommend to install some kind of a remote desktop application, and that will be just much faster. So now also let me run a demo with remote visualization with Tram. So Tram is a package for creating web dashboards into which you can do some very fancy visualizations, and it relies on a service. So I'm going to install Tram on this machine, and then I'm going to run a demo where I will serve visualizations on port 8080, and then I will access these visualizations in my browser. But before I do this, I actually need to copy some code from my machine. So let me run these commands. So I need to copy the code for the web application. So, and the data set itself, I'm going to visualize. So let me do this very quickly. And then so I created a gzip tar archive that I'm going to, for this demo, I'm going to copy it to my virtual machine. And then in the virtual machine, so I'm going to SSH as usual. And then I'm going to install a few packages. So first of all, I need the X11 rendering extension for this demo to work. So done. Then because there is no GPU in this virtual machine, I'm going to be doing rendering on a CPU via OS Mesa library that I need to install as well. So that will take a few seconds. And then after this, I'm going to create a virtual environment, and then into this virtual environment. So first, I'm going to install UV to be able to install Python packages. So here I'm installing UV. So here, notice that I'm doing all of this on the virtual machine that I just created. So UV is installed. I'm going to create a virtual environment using Python 3.12. Then I'm going to source this environment. And then into this environment, I'm going to install a number of packages. So things like NumPy, and then Tram itself, and then very strong components that I needed to run this demo. So all of these things, as you can see, installed very quickly with UV, just a few seconds. And then I need to install this guy, and then to install a VTK as well. So with all this installation out of the way, I'm going to unpack my demo files, and then I'm going to run the demo. So done, I'm going to unpack my demo files, and then I'm going to run the demo. I will paste this command, and hopefully it works. So let's see. But I think I installed everything that is needed. So, okay, so yeah, these warnings are not, so failed to load EGL means that it did not detect any GPU, so it's switching automatically to software-based rendering using OpenMesa. And now all I need to do is open the following port, do the following in my different tab in my browser. So I'm gonna go here, and then this is the IP address of my machine, and then I'm gonna go to port 8080, and things work. So as you can see, here's my visualization that I created on a brand new machine that I just started, some like 10 or 20 minutes ago. And here I can actually do visualization. So here I can switch to, let's say, isocontours by velocity, and everything works really, really beautiful. So as you can see, I'm running a server on port 8080 on the virtual machine, and then I made sure that my traffic on port 8080 reaches the machine by creating this new rule and then allowing the incoming ingress traffic on port 8080, and everything works really beautifully. Okay, so if you want to save your machine, you will need to create an image snapshot. And the snapshot will include the operating system, of course, so in our case, Ubuntu, then all additional software packages and perhaps your configuration files, and then all data from the root and system disk. So to create a snapshot is super, super easy. So the command for this is OpenStack server image create a snapshot, right? So this is going to be the name of the snapshot, and this is the machine I'm backing up. So a snapshot is essentially a backup of my entire virtual machine minus the ephemeral disk on the cloud system. So let's do this. Let's do this very quickly. So here I'm gonna log out, right? So I need to run OpenStack command on my computer. So I'm going to be creating this backup, the snapshot called Alex demo image of my virtual machine. So this might take, I don't know, up to a minute, because now it's picking up the entire virtual machine. Actually, here we go. It created this image. Then I'm going to list all images that I have access to. So we ran this command before to check for various operating system images available to us. And now notice that there is an additional one, this guy, right? So how this guy is different from this guy? Well, here I also installed a few packages, right? So that's essentially the only difference. I installed a few packages, but essentially now this is a copy of my machine. Then I can, destroy my machine in the next step, and then I could spin up a new virtual machine instance from this image, and that will contain, will have the packages that I installed into this guy. So as I said, these only save data from the root or system disk. So this does not save data from the, in our case, 31 gigabyte ephemeral disk. There's actually no easy way to save this data. But what you can do if you put a lot of data on your machine, you can actually put this data into a volume. So in our case, we created earlier a 100 gigabyte volume. And then I can actually snapshot the volume itself. So to snapshot the volume right here, snapshot attach volume, the command for this is OpenStack server. The first thing I need to do is I need to detach the volume from the machine. And this will make sure that anything that is sitting in cache is written to the disk. Then I create a snapshot using this command. So I'm calling this snapshot data volume. So here I'm just snapshotting the data snapshot. I'm snapshotting, so saving to disk, the volume called demo volume. So that's the 100 gigabyte volume that I created earlier today. And then once the snapshot is created, I can reattach the volume back to the system, right? So the idea is that when you create a snapshot of a live volume, you probably want to detach it first to make sure that all buffered I/O, all buffered output is written to this disk, and then you can create a snapshot. So if in the future you want to delete a snapshot or a volume snapshot or image snapshot, these are the commands you would use, right? So very easy to do this. And then finally, to destroy the machine itself and all associated resources, here are commands. So the command, before you destroy the machine itself, you probably want to dissociate the floating IP address, because if you try to destroy your machine as is, it won't work. Actually, in my case, the first thing I need to do, because I have a volume attached, I will need to actually detach the volume. Then I will need to delete the volume. Then I will detach the floating IP, and then I can go ahead and destroy my virtual machine. And then when I do once successful, this destruction usually takes a couple of seconds. Then when I run OpenStack server list, won't do it now, but when I do this, you will see that your machine is no longer in the list of active instances.